help demonstrate. Come here, Haley. Look at the camera. Open up to Explore 1 Activities Spring Waves, and you're going to set it up like this. You have a slinky stretched out. This line, because there's no motion yet, is called the origin. Sometimes I'll call it the rest. Sometimes I'll call it equilibrium. They all mean the same thing. You're going to start off by sending a wave impulse in 90-degree angles to the direction of the motion. It looks like this. Just hold it steady, Nora. Your drawing should start out something like this. That's what we created with the slinkies, and later we'll go about labeling the diagram. So there's a couple different things you can try. You can try increasing the distance you move your hand side to side, and then you can also increase the speed that you're moving your hand. This is the transverse wave that you drew in the beginning, but now it's labeled. So the first question that you're answering is, when did the wave have the highest amplitude? There's two places where you can find amplitude. It's either from the crest or the high point to the rest. I remember it because it's rest to crest and it rhymes. You can also, it's the same exact distance from rest to the trough or the low point. That distance is your amplitude. So when you saw the two different types of waves, was the amplitude the highest when I moved my arm highest side to side, or was the amplitude the highest when I moved it the fastest? Question 3 you should already be able to answer. And question 4, when did the wave have the longest wavelength? That's the distance from one crest to the next crest, or it could be one trough to the next trough. So did it have the longest wavelength when I was moving my arm further from side to side, or when I was moving it quicker back and forth? Number 6 asks you to sketch what happens when you're challenged to move it as many times as possible. Please hold it steady, Nora. Number 7 asks you to sketch how the waves look when you're challenged to move it as slow as possible. Question 8 asks, the frequency of these two waves was different. What do you think frequency means? Haley's standing at the X, so we're going to take a look at how many waves, or the crest to crest, pass by her foot, or that X, in a couple seconds. Not too many there. A lot more passing by there. The higher the frequency, the more waves passing by a point in a second. Go ahead. Can you send me some waves? Go! Go! So for question number 9, parts A, B, and C, you're on your own. Use what you've learned throughout this video to complete those 3. Then you'll have a claims, evidence, reasoning. For the claim, I'm going to give you the relationship between wavelength and frequency, and you'll be responsible for the evidence and reasoning part. The claim: as frequency increases, wavelength decreases. Just some reminders, when you do your evidence, it should start with something like, when we made waves such and such way. It should be relationships to what you saw in the video or what you did with your slinky if you had them. Then your reasoning should be more of the scientific generalization of the relationship between